Hello, Mr. Colati here, and today we are going to begin Chapter 5, which is all about probability. Now, probability you've probably encountered at some point in your life, the idea of it. Maybe in high school or grade school you did some questions about it. The probability is the likelihood or the chance of something occurring. And when we look at probability, we talk about all the different outcomes or all the different events. So an event is one possible outcome. The probability of that outcome, of that event happening, can be represented as a probability. Probability is a number between 0 and 1. So here I would write, for example, the probability of event A occurring. This is P at A. Probability of event A occurring. And we should just note that the probability that we just found has to be between 0 and 1. And let's just talk about what we just wrote. Actually, I find this diagram helps a little bit. So, for example, you can roll a dice. And we can talk about the probability of getting a 1, getting a 2, getting a 5. These different numbers that you can roll are the events. So there are 6 events or 6 outcomes possible with a dice or die. And the probability of each one occurring is between 0 and 1. Any probability is between 0 and 1. 0 means it's impossible, it's not going to happen. 1 means it's absolutely certain. You have 6-sided dice. Each side has an equal probability of occurring. So you have a 1 in 6 chance of getting, say, rolling a 6. If you have a higher probability, so it's closer to 1, it's a lot more likely it's going to happen. And if you're right in the middle, you're 50-50, this is your even chance, so 0.5 probability. It's like flipping a coin. You flip a coin, you have 50% chance you're going to get heads, 50% chance you're going to get tails. Now, when we start talking about probability, we're going to look at 3 different ways we can decide on the probability of something. The first is theoretical probability. This is where we use math to analyze the system. For example, a coin flip. I can analyze that system, look at all the possibilities, and then tell you my probability that I'm going to get a heads. This is what we're doing in section 5.2. We could also find out the probability of something occurring experimentally, or an empirical probability. This is where we run a million tests, or we run many tests to determine the probability. This is what we're doing today, experimental probability. For example, basketball free throws. The probability that you're going to sink a basketball shot, well, I can't really use math to analyze your free throw ability, but I can see how well you do when you do 1,000 free throws. So this is today, 5.1. Another way you could decide on a probability is just based on intuition. That's subjective probability. We don't really do this. This is not part of our course, but this is something you might hear, when you hear people talk, like, "Oh, I'm 99% sure I just aced that test." Well, that probability, 99%, is very subjective. That's not based on math or experiments. So be careful when somebody gives you a probability that is just subjective. Okay. Now, just before we go on, I do like to think probability is everywhere in your life, and you might not think about it, but somebody has determined probability for a lot of things, and you are doing it all the time too. And sometimes you do it theoretically, where you analyze the system. Sometimes you do it where you run experiments, and sometimes you do it subjectively. For example, what is the probability that a student will break their phone before they are eligible for a new one? So think about this. A phone company wants to know this probability. It helps them know how often you're going to need to buy a new phone, so how often they should make the plans last for. They can't run a math to figure out how often you're going to break a phone, but what they can do is look at, for every user, how often they break their phone, and they can figure out the probability that's going to happen to you. So this would be experimental. What's the probability that a COVID vaccine is effective? So once we have it, how will I know it's going to work? Well, I could analyze the science of the vaccine, but really I have to run a test. I have to give the vaccine to 10,000 people, 50,000 people, and figure out how many people don't get sick. So this would again be experimental. What about the probability it will rain tomorrow? Well, you can't really run a test about it because it would be too late. If you want to be able to predict whether it's going to rain tomorrow, you need to be able to analyze the system and figure out the probability it's going to rain based on all these, based on all your analysis. So this would be a theoretical probability where you've actually used, you've analyzed the system and come up with a model. And here's another one. What's the probability that President Trump is reelected? So, I mean, this could be, I like this one because it could be anything, right? I could go to a website and look at polling numbers. That's where we call a bunch of people and see what they say. So that would be experimental. Again, this isn't the fact, like, once election nights happen. This is our prediction, our probability before election night. So I could call up a bunch of people, and then I would be able to look at all their results and make a guess about the probability who's going to be reelected. Another website I go to for election news, they analyze the system, so the 50 states, and how if you win different states, it adds up to a win. And so they actually do it theoretically. They look at each state on a state-by-state basis. So we call this the electoral college. We're not going to go into this too much. This is how the U.S. Election system works. But when you look at the electoral college, you're really looking at the system, and you're analyzing the system to see how you can get enough votes to win. And finally, I mean, it could be subjective, right? If you watch the news or fake news, they're going to give you another probability. So that would be subjective, maybe. So probability is all over our life. Again, this isn't what's happened. It's the probability we think something's going to happen. Okay, so let's get started with experimental probability. So this is where I run some tests to figure out the probability. So usually what I do in class, and we'll try to do this simulated in this video, but I get a bag and I fill it with these blocks. So there are 10 blocks in my mystery bag. So, and they're 3 different colors. So you don't know what's in my bag, right? It's a mystery to you. This is the bag. There's the blocks right there. You can't, well, you can kind of see through, so I won't hold it up there very long. So if I want to figure out the probability of getting a certain color, I can't analyze any math, but what I can do is I can pull blocks out of the bag. I can run a bunch of tests. So here we go. I'm going to reach into the bag and I'm going to pull out a color. Green. So that's one of the colors in the bag. I got it once. I'm going to put it back in the bag. I'm going to draw again. I have to do this 20 times. Oh, I got another green. Okay. Okay, yellow. Okay, this is where you're going to want to fast forward the video. This is going to take forever. Red. Okay, those are my 3 colors. I have to do 20 trials. Now I know what the colors are, you don't. But whatever, I'm just randomly grabbing in, not looking. Oh, that's not a problem, I'm not going to count that. Green again. Red. How many is that? That's 5, 6, 7, 8, 9, 10. Wow, red. Oh, jeez. Got a lot of red. Green. Green again. How many have I done? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, we still have to go. 14, 15, 2, 5, 6, 7, 8, 9, 10, 15. Oops, sorry, put that back. 16, 17, 18, 19, and 20. This is how you get your YouTube hits up. You just have really long videos, right? Okay, so I've ran my 20 trials. Let me count this up then. How many did I get? So I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 green, 2 yellow trials, and 1, 2, 3, 4, 5, 6, 7, 8. 8 red. Okay, so now can you make a prediction about what was in my bag? Remember, there were 10 blocks. What would you do to make a guess? I mean, I think I can tell that there aren't very many yellow in my bag, right? Because I only grabbed the yellow twice. What I would say is, okay, well, what you might say is, okay, I did 20 trials. 2 of them were yellow. So my bet for yellow is that you had 2 out of 20 trials, which would be maybe, okay, so I had a trial, sorry, 0.1, that's 0.1. So I would say maybe 0.1 of 10 blocks. So therefore 1 yellow block. Maybe you did some math like that. Similarly, I have, for green, I have 10 out of 20 times 10, so I would maybe predict that 5 of my blocks were green. And for red, then, what would the remainder of my prediction be? 1 yellow, 5 green, so maybe 4 red. Right? This is my prediction. So, let's see what it says. What happened? So I had all the drama, the big reveal. So I had 1, 2, 3, 4, 5, 6 red, 3 green, and 1 yellow. So I was a little off actually. I said 1 yellow, 5 green, 4 red. Too bad. Should I write what I actually got? But it was actually 1 yellow, 6 red, 3 green. Okay, so this activity that we just did, this is a way we can find out the probability that something's gonna occur for a system we don't understand. It's called a Monte Carlo experiment. It's Monte Carlo, I don't know if you've heard of it. That's a famous casino in Europe, very fancy casino. So this is, people were trying to analyze systems there. They would run experiments, and so that's where we get this idea from. So think about it, like some of you, when we did this in class, you'll often get the right answers. Your predictions will be right. Because as I do a bunch of trials, even though I can't see in the bag, I begin to understand what's in the bag. I only get yellow a few times. I know there aren't very many yellow blocks. Now, what I usually say to the students, how could I make sure my estimates were even better? How could I make sure that I actually get it right? Well, I would do a lot more experiments. Can you imagine how long that YouTube video would be? I would do this 100 times, 1,000 times, 10,000 times. As I do it more and more, I'm going to get a really clear picture of what's in the bag. And I'm going to be able to know with higher certainty the probability of getting green, the probability of getting red, the probability of getting yellow. So this is what we mean when we're talking about experimental probability. We have a bag, or we have some system that we don't understand. We can't design math to explain what's in the bag. It's a mystery to us. The only way to solve it then would be to run experiments. This happens all the time. We talked about some examples before. Some other examples, like if you sell ice cream, You want to know which what's the probability people are going to buy orange ice cream, because then you need to buy more orange ice cream. So you would see every year how much orange ice cream sells, and then you would know the probability that it's going to sell out and you need to buy more. Let's say you're running the prom for the school. What's the probability that a student's going to actually go to prom? Because we need to know how many seats to have, how much food to buy. Well, you can look at past years. You can see that, usually 80% of the students go to prom. So you can run that experiment look at the data from each year and figure out the system a little bit better. So even though we do not know the probability that something will happen, we can make an estimate by conducting a series of trials, or what you might call experiments, in order to determine experimental probability. So let's turn the page. So the way that we found if you look at what we were doing here, to find the probability of getting yellow, I took the number of times I got yellow, 2, out of the number of trials. So 2 out of 20 means the chances of getting yellow, I thought, was 0.1. So that's how I find the probability. I actually call it the relative frequency. So the relative frequency is equal to the number of times an outcome occurs divided by the total number of trials. And what we just discussed, the relative frequency is only an estimate of probability, but it gets better and better if you have more trials. So that mystery bag, if I had had 1,000 trials, it would have taken forever, but I could have figured out, I could have had a better guess at what the probability, the probability. If you think about your favorite movie, Avengers, Infinity War, Doctor Strange can look in time and see, run all the different trials. He can run 10 million versions of the battle and figure out that the probability they're going to win is 1 in whatever it was, 5 million or whatever. Okay, so let's do an example of this. Helena successfully made 21 out of 30 free throw attempts. Again, I can't really analyze Helena mathematically to determine how she's going to do with free throws. I can just get her to do a bunch of free throws, run a bunch of experiments, and see how well she does. So the probability that she gets a successful free throw is 21 out of 30. If you want, I can write this as a decimal if you like that better. 21 divided by 30 is 0.7. So the probability of A, that is, the probability that she gets a successful free throw, is 0.7, which is pretty good. That's not bad, right? It's a pretty high probability. We might as well define right now PA complement. That's the probability she doesn't get a successful free throw. So that's 9 out of 30. That's a lower probability, right? So A complement, sorry, did I say prime? I meant A complement is not a successful free throw. And we're going to talk more about this in a few lessons. If you wanted to compare Helena to another student, you could get them to do 30 free throws and you'd see how they do and you could find their probability. Now, in a playoff game, Helena makes 20 free throw attempts. How many of these does she sink? Well, you can say the chances of sinking them is 0.7, so I'm going to multiply that by 20. So if I want to do this with my calculator, I get 14. So that would be my my guess based on the probability. I would guess that she sinks 14 of the 20 free throws. It's an estimate based on experimental probability. Okay. Fortunately, no homework for this. No homework until we get through the second section. So good luck digesting this, and we'll see you next time.